Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, Alhamdulillah, today is our first topic on Fundamental of Communication Engineering. I'm using this book, Contemporary Communication System. MF Mesia is the author. Okay, so let's see what is the definition of communication in general, or under the Webster's Dictionary. It says that communication is a process which information is exchanged between individuals. Okay, whether it's a system like telephone or something, or our computer, and also signs of behavior like we are talking or give sign to our friends. Okay, another definition is interchange of thoughts, opinions, or information by speech, writing, or signs. Okay, in this book, it says that communication is a transfer of information. Okay, the goal is to produce or reproduce as accurately as possible that particular message at the receiver that sent from the transmitter. Okay, so this communication system will convey the information in the form of electromagnetic signal. Electrical communication system will enable interaction at a distance almost instantaneously. For example, as we are having right now, study or learning almost instantaneously. What I'm talking, wherever you are, you can listen instantaneously. Or right now, you can call your mom or your father anywhere and they can listen instantaneously. Okay. So, the most important point for an electrical communication system, the communication must be transferring of information. Okay, so it can or enable interaction at a distance almost instantaneously, and it will convey or transfer information in the form of electromagnetic signal. And lastly, the signal at the receiver has to be the same from the signal at transmitter. So that is the goal of a communication system to be transmitted. Alright, so for example, if we want to make a phone calls, okay, so we send a message or we are talking at this side, at the transmitter side, so that signal will convey or transform by a transducer to become an electronic signal. Okay, so this electronic signal will be processed to be enabled to be transmitted at the transmitter in the form of electromagnetic wave. So now our message are in the form of a wave or electromagnetic wave. So this wave will receive at the antenna of the receiver, and this wave is going to be transformed again into a signal that the ears can listen, right? So there are a few types of message signal. Uh, if we speech or talk to our friends or family, it's going to be a speech. Okay, sometimes we listen to music or we send image, and we can also send videos, and we also send data or documents or text, okay, via a system. Okay, there are there must be 5 elements of communication system. For the first one, it has to be a source. Okay, there must be a source or message that we want to transmit. So this message or source will be an input message of the transmitter. So the transmitter will convert the message into a signal. Okay, now the transmitter or the transducer will convert to be transform or transmission over a physical medium or channel. So this channel is a transmission medium where our message is here. So it can be, there are 2 types of channel, wired medium and wireless medium. In this channel also, it will have interference or noise where it can reduce the power that convey our message. Okay, so in the receiver, the receiver, because it has been interfered or distorted or attenuated, it has to recover the original message from the attenuation or any distortion or any noise. Okay, and the output message has to be as accurately as possible as the source to be listened or received at the destination. Okay, so for the channel just now, this one, it can be wired media or wireless media. So wired media, it is in the form of a cable, or there are many types of cable. So we cover the most general one, which is the TWP, twisted wire pairs, coaxial cable, and also optical fibers. Okay, in the wired media, so it will be wired there, so it will be contained and guided within a solid medium. Okay, it has to be um, something that can conduct electricity. Okay, so the signal can be sent from a point to another point, connected, okay, via a physical link or a channel, right? So this is the example. And then the second one, we have a wireless media. In this type of wireless media, the signal will propagate in the form of unguided electromagnetic waves. That's mean the signal don't have a physical link. Okay, so it can propagate in the air. Okay, so usually this type of media is for broadcast mode, so many people can receive this kind of signal. For example, the FM radio, many people can listen to the radio with it without limitations. So it can be shared by everyone who have the encoder or um, demodulation type of signal. And then, for example, if you want to send message to people at the archipelago of an island, for example, there are many islands, but it has when it comes to a wired media, it will be very high cost because we have to connect it between place to places via the ocean, through the ocean. So the wireless media or broadcast type of medium is going to be easy to share the information. Okay, most of the time we see this kind of um, system, such as FM radio, the radio in our car, infrared, our touch and go, our Bluetooth, telephone, of course, and also the Wi-Fi, and the most or the most we know for broadcasting is the satellite TV. Okay, so there are two type of channel. Okay, so this is an example of point to point connectivity. Okay, so if we see in our house, when we want to install Unify, for example, or there are many more other internet service provider using cable, we can see that the cable is taken from a building. So inside this building, there are a lot of wires that identify your house. Okay, for example, if you want to get a telephone line or internet line, we will be uh, we will be assigned to a channel from a certain point. Okay, in this system, okay, in the infrastructure. But right now, this is old phone line. But if you are using cable or Unify, they actually put the wire inside the ground. Okay. So for another example is the ISDN modem. If we have a telephone line and then we can get internet via a modem. So as long we have this telephone line, it can convert into data and we can use internet, okay, voice over IP signal. Okay, also there are ADSL modem that converts the signal from our telephone by a splitter so it can goes to our PC as a modem. Okay, so from there we can get access to the internet. Okay, so this is example of a wireless media. There are lots of example that you also know, from gaming, printing. Right now we have also IoT to connected from device to device or from sensors to sensors wirelessly. Okay, our remotes, okay, and our computer connected to Wi-Fi. So most of the time people are avoiding this cable or wired so they can use things without um uh, without point to point, like without wire. They like mouse also we want wireless, right? But the disadvantage for me if we use wireless mouse is we will keep on changing the battery because the wireless needs power to transmit, but if using cable they are taking the power from the computer. Okay, so I prefer, after I tried the wireless one, so I prefer actually the wired. Okay, and then also there are also example. Okay, before we go to other example, we go the detail about TWP. Okay, the TWP will consist of two insulated wires. Okay, inside here, the blue or the white one, the two wires is insulated. So it inside there is a copper or copper clad steel is twisted. Okay, so in this wire, there are also type that shielded or unshielded. So as we know, if it's shielded, it can reduce interference or to reduce crosstalk, because if the first wire is uh, connected to the second one, we can listen the other people conversation. Okay, there are various thickness and also the attenuations would be also high, around 1 to 4 dB per mile. Okay, so it can goes also at 1 kilohertz, but it's the price is cheaper than coax or fiber. The fiber is the most expensive one. Okay, so this is one of the example POTS. There are modem, SDN, ADSL applications. Also, if we have inter-building wiring, we also use this twisted wire pair. Okay, so this is the attenuation for different types of TWP cable. But as you can see, if the frequency is increasing, the attenuation also will be increased. The second example of wired media is the coaxial cable. So the coaxial cable can go to 1 gigahertz bandwidth. So in this 1 gigahertz bandwidth, it will divide it into lower bandwidth, or we call it different channels. So each channels can goes up to 6 megahertz. Alright, so it can also use for entertainment programs, POTS, and also high-speed internet services that have speed faster than the TWP. So if we see the how this coaxial cable is designed, it has a dielectric material and also outer conductor, and then it also insulated with a jacket. So it has a very excellent immunity, but fiber is the most immune to the noise. So between TWP, coaxial, and fiber, the most immune is the fiber, and the least one is the TWP. Okay, so this is one of the example of coaxial cable, the CATV, and also LAN applications. Alright, so basically, if you want to use the this type of cable, the each cable will use for different frequency. Okay, for different frequency, there will be different attenuation. So this is type of coaxial cables. So we see this cable usually in the communication system where it using high frequency. Okay, so each cable actually we have to know what is the frequency, what is the attenuation, and how far it can go. Okay, so every miles or every distance we can calculate the attenuation. Okay, the last one of the wired media is the optical fiber. So in the optical fiber, inside here is the glass core. The outside is a layer of glass called cladding, and the outer one is the jacket. Okay, so the lights will be transferred. So this light will bring information. So the information in the form of lights will be reflected in the glass core. Okay, so this light propagates using total internal reflection. Okay, so this one is we call the refractive index. So this dielectric constant is different from this one, so it will be reflected inside the glass core. All right. So this is how it looks like. It's like a um, lights. Okay, lights means inside this where the signal or information is, or you can see also here this one. This light will bring the information. So this one can bring many channels. So you just imagine how a fiber can bring uh, very high frequency with many users inside here. So it's actually very costly to just put one, that's why it's very costly to put one fiber cable to get the connections of our internet or TV, for example, because actually they would prefer that if the place has many users, so it can cater the size of this fiber cable. Okay, so in the fiber cable there are also different mode to transmit the signal. So basically you will learn this in detail for the fiber optic subject in your fourth year. Okay, so an optical fiber has very low attenuation, which is 0.2 dB per kilometer, and the wavelength is very small, 1550 nanometer. Okay, just imagine the wavelength is very small, so the frequency is very high, and here it explains the bandwidth is up to 30 terahertz. So in this 30 terahertz, there will be windows. Okay, we will see how it looks like later. And as I said or mentioned before, it will be very less immune. Okay, very or it it will have high immunity to noise. Basically, it won't affect so much to the noise. And uh, I'm sharing here the advantages and disadvantage of fiber. It has high frequency with huge bandwidth, and it can divide it into many channels or users, and it very immune to noises, and not like the TWP or coaxial cable where we can actually cross talk where the if the cable is connected together, but this one is very um, coated uh, coated, so no crosstalk, and the size is very light, and there is no corrosion, not like the uh, cable from TWP or the coaxial, and it does not affected by temperature. Okay, but the disadvantages is the cost to install it very expensive and also difficult to install. Okay, it needs a very high tech machine to just connect it the fiber if it broken, or you want to make a continuous fiber, or you want to connect a fiber, it needs a special machine. Okay, so this is what we call window. So the attenuations is also very low. If we compare the twisted pair, coax cable and also fiber, the fiber have very low attenuation unlike the twisted pair. And the frequency also very high for the fiber optics. Okay, so as a communication engineer, you have to know what kind of connection that our user is requesting. Okay, in terms of type of cable, there are different type of cable. Also, we have to know what is the distance from the user to the service provider. Okay, for the fiber cable, it can goes up to 70 kilometer. Okay, so it can actually reach very far away, and also it can go across ocean. Okay, and there are also speed of each of the media that are being applied. So this Ethernet standard is actually the standard given by the um, ITU, International Telecommunication Union, for different type of user. Okay, which one they are requesting. Okay. Okay, when we are just now we have explained on the type of wired media. The second one is the wireless communications. So when it comes to wireless communication, there are wide range of frequency. Okay, it can go to very short distance like our Bluetooth, or it can go far thousands of kilometers, just like the satellite broadcast communications. We can also see this wireless or broadcast communications, wireless communication in the petrol pump where we use our transactions, credit card, or we want to um, um, to our money in the ATM. So there are small VSAT at the petrol station. Okay, and talking about wireless communication in mobile, in our mobile, it goes to 1G to right now we have 5G. Okay, so the 1G, if you can recall, we can only make phone calls, but when it comes to 2G, it can send you a message. Okay, and then when it comes to 3G, it can send you pictures and also videos. Okay, and then when it comes to 4G, there is a data where we can browse internet in your phones, and then with 5G actually it's going to be the expectation is going to be faster, low latency, and also it can connect multiple device with one connections. Okay, so just now I've mentioned that if it's for a different type of applications, okay, it needs different wavelength. Okay, so this different wavelength are related with the frequency. Okay, so the radio wave, the wavelength is 10 to the power of 3, and it goes very small into gamma rays, which is the wavelength is 10 to the power of minus 12, okay, which is in the size of a atomic nuclei. So at this point, the frequency at very small wavelength, the frequency is very high. So it inversely proportional, the wavelength and also the frequency. And also what we see usually, we are talking about radiation. Radiation is related to the temperature of the uh, intense wavelength emitted. That means the smallest or the very small wavelength for example, for we use X-ray or gamma ray, the radiation is very high where it can sometimes to kill a tumor, or we can do for medication. Okay, um, for a radio channel, some of the important point that you have to take note: this electromagnetic wave will propagate through space. Okay, it's the channel is in the air, so the frequency spectrums are also very limited or scarce in this world. Okay, for example, in Malaysia, the frequency spectrum is decided or determined by the Malaysian Communication and Multimedia Commission, MCMC. But MCMC are also instructed by the ITU of the International Telecommunication Union. So for example, if Celcom, we know that the frequency of mobile is about 900 to 900 and 1800, but that one is very general. So Celcom is actually take a portion, very small portion, that they have to register with MCMC. Same with Digi, same with Maxis. So every company has to bid this frequency spectrum with MCMC, and they make rent or lend this frequency spectrum. So if they come more than that, they can be uh, summoned. Like that means they are going take somebody else frequency spectrum. So, and our walkie-talkie, for example, it has to be 400 megahertz VHF, so it cannot go more than that. So if somebody having a walkie-talkie, and they have to follow the frequency spectrum that are assigned to them. For example, we cannot use the X-band frequency because it is given to the military. So the military are using somewhere 8 gigahertz X-band for their communication system. So we as civilian, we cannot use that particular frequency. Okay, so an important point also, if an excellent attenuation characteristic over long distance in specific frequency bands means that if you have a very long distance, you have to be aware what is the attenuation. So different frequency band will have different attenuations according to the distance. So how do we want to know that one? There is a equation for each system. Okay. So this is the one that I've said, the different spectrum allocations. For example, for VLF, very low frequency, the range from 3 to 30 kilohertz usually are for radio navigations. Okay, and then also marine mobile communications, mean the ships there, they use this VLF. Okay, so let's see for our FM radio, we can see in our car the channel is all among in the range of 80 to 108 megahertz. So it has to be in that frequency range. And then for our cellular telephone, almost 900 megahertz. Okay, and then our Wi-Fi is 2.4 megahertz. Okay, and the satellite communications, there are several band, and then our Astro is between this band 12 gigahertz, and also coming is the Ka band. Okay, all right, so this is the frequency spectrum allocation for various application, just like what I've explained before this. Okay, so the elements of a communication block diagram, it must have a transmitter, a channel, and receiver. So at the transmitter, we will send informations and also a carrier. So these carrier are responsible to bring the information into a channel. So at the channel, it's like a transport. It will goes to the receiver and receive the signal and demodulated to be recovered. So we can get the information as the one that we transmit. Okay, so this example of a cellular phone networks, if we have a, for example, in this pandemic, we want to make a call. Okay, so there is a base station at Sabah and the base stations at Kuala Lumpur. If you are moving, so actually there are a radius of that particular base stations. So we are moving from one base station to another base station. So this base station are contacting the service provider or MPSO, and this MPSO will contact other MPSO service provider. So this one will call or contact the base station of the receiver at other station. Okay, so this is wireless LAN. To transmit the internet, we use a LAN for wired, but if wireless LAN is the wireless. Okay, and then we have satellite system. So this satellite can cover very large area. So there are many locations that actually this satellite can be located, ranging from very low Earth orbit, LEO, about 2,000 kilometer, or can be up to 39,000 kilometer, GEO satellite. So the farther away the satellite located, it can cover larger area. Okay. And then this is a paging system, just like our telephone, but it can only give you signal. Okay, very old version of phone. And then we also have Bluetooth. You know, if you just very short range communication, it using the 2.4 gigahertz. Okay, and then this is the revolution. I also mentioned this one from 1G to 2G and also the 3G. Okay, so what the difference is the generation. That's mean the type of signal that it can transmit. Okay, so in the wireless propagations, BS is the base station. So actually there are many effects to come to our receiver. So some of it is a reflection. So when it has a building, it reflected, and then it comes to your receiver. If it has a interference in the middle, such as the trees, it can also have this effect of shadowing, or the signal transmitted here but it's scattered to other path, and that makes the signal attenuated more. And then lastly, they also can come to the receiver. Okay, so this is an example if you want to calculate the attenuations. So for the attenuation to be measured, there are many types of environment. For example, if it's a free space, okay, the general equation is loss equivalent to 10 n. N is the type of environment, okay, here, and log 10 of the distance. As we know, the farther the distance, the attenuation will be higher. Okay, if we have some category of environment, the free space, that means it's a clear sky, so it can directly to receive here, receive to the from transmitter receiver, no interference, you use the N as 2. Okay, if at urban area where there is a cellular radio, just like Kuala Lumpur City Centre, is going to be 2.7 to 3.5, means this one it will be higher. Okay, if a shaded urban, means there are a lot of trees at an urban area, 3 to 5. Just now we have seen that if shaded with something, the signal will be much loss. Okay, if inside a building where there is a line of sight, the N will be 1.6 to 1.8. Okay, so if the signal is obstructed in building, that means it will have a diffraction and a reflection effect. It use N4 to 6. Okay, and if obstructed in factory, 2 to 3. Okay, these values are actually proposed by an experiment or a research. Okay, so it can be actually varies from different values, but for reference we can use this one. Alright, so there are also advantage and disadvantage of wireless media. So if we are talking about microwave frequency, it has a very high bandwidth, but must the disadvantage is it cannot be obstructed by line of sight. So it very sensitive to the interference by the environment. And we also have wireless channel that comes from a satellite, which is a higher frequency. It can transmit high bandwidth, cover very large area, but it's very expensive to launch a satellite. And it also has to be line of sight, okay? And there are delay in the propagation due to the very long distance of the signal's transmission. And for because it can broadcast to everyone, shared by everybody, so it use very high encryption for security. That means we have a very high encrypted or encoded decoder in order for us to receive that particular signal, because it a shared media. Alright, so for a radio, it also have high bandwidth, and this signal can pass through walls where we can listen inside building. It's also inexpensive, but it has a lot of interference problem. And it also have a snooping, where we can get the signal for free unless it is encrypted by the owner or the decoder itself. Alright, so for the infrared, very low bandwidth and short distance, and it also needs a line of sight. Alright, so for the channel, we can see there are wired media and also unwired media. So we have twisted, shielded, unshielded, coaxial cable, and also fiber optics. And for the wireless media, we have radio transmission, which is in low frequency, and also microwave transmission for high frequency. Okay, so before we come to the end for this chapter 1, I would like to also emphasize that in communication system, there will be analog and digital communication system. So in our subject, we will cover this analog communication system, AM, FM, and PM. Okay. So this one we will learn next semester. Okay. So for an analog communication system, we will convert this analog message into a waveform that's suitable for a communication channel. So we must have a when we are talking about modulation, we will have the amplitude modulation, phase modulation, and also frequency modulation. Okay, so this modulation will be modulate to the carrier that come with or along the message signal. So when at the transmitter we modulate and at the receiver we'll demodulate to recover the original signal. Alright, so as I mentioned, during the transmission period, we will have the noise and other channel impairments. The most application that use analog system is the AM and FM broadcasting. Okay, so this is the block diagram of the analog communication system. For first of all, we have this analog source, and then this analog modulator will modulate the signal with a carrier, and then the transmitter will bring the output processing to a channel. Okay, so that means this is the transmitter. This channel can be can be wired or wireless, and then there is also noises that come across this portion. Okay, at the receiver, it will receive the signal, and we have a demodulation process to recover the message signal at the destinations. Okay, so that is the main block diagram of the analog communication system. We have and must have analog modulator, demodulator, and we have to consider the noise at the channel. Alright, so for example, if we have a CATV, coaxial cable television TV, okay, so at the head end, we have this kind of signal. So using the coaxial cable segment, so the amplifier will help this signal to be amplified. So it will have a better strength to be transmitted via a channel. So this amplifier will ensure the signal that has been dropped due to attenuation to be increased. So when it come at the converter, it will identify the original message accurately. As the system length increases, the output of this coaxial cable will also increasingly attenuated. So that's mean the longer the length, the attenuation also increase. Okay, so that's why we have amplifier or repeater, we call it, to restore this signal to its original form. Okay, so along this way, the signal will be distorted, and there is also noise. So that's why we have this amplifier, and noise will be removed by a filtering technique. Okay, now we come to digital communication system as an introduction. So when it comes to digital, the message has to be a sequence of symbols from a finite alphabet. Okay, the characteristic can be like words of Chinese or English or binary symbols or computer file. So if this source is analog, it can also be converted to digital or vice versa by adding the AD conversion or D to A, digital to analog conversion process. So these are some of the example of a digital communications. Okay, for a block diagram of a digital communication, we will have a bit longer or complicated block diagram where the first one is the encoder, because the encoder has to encode the information to be uh, to produce an efficient. So for example, we have signal, so we will have to encode it into a digital like 1 to 0, a sequence of bits, okay, to be encrypted, and this signal will come to a channel encoder, so it introduce a control manner of the source. Okay, so the interface of this one we call digital modulator, and after it goes or transmit to a channel, it comes to the digital demodulator. So this digital demodulator will process the channel, whether it has noise and whether uh, it, it can estimate the sequence to be transmitted. And then we have also decoder. After this, all the signal have been encoded, we decode back, and then the source decoder will reconstruct the original signal. Okay. Okay, so most probably we have known that many of the applications are in digital. Okay, so why we prefer digital communications is actually it has wide range of applications. Okay, although some of communication system are using analog, for example, in the ships, they use this analog communications for communicate among the crew inside the ships. There are also FM, also an analog. There are a few other more analog, but the digital communication is widely used. Okay, because of its ease of regeneration. Okay, and also this signal can be used for many services, and the power to transmit also very low. Okay, so with this digital, there are many capabilities that we can use to enhance the system, and it has very high security. And also the digital communications also agree or predicted by the Moore's law. So the Moore's law says that the number of chip will be double from years to years. That means just like today, we have been using many digital applications and gadgets. So the amount of uh, uh, the amount of the digital application is double year by year. Okay. Okay. So this is the explanation on how digital communication is easy to generate. Okay. So because it use bit like 1010, Okay, so as long as we have put it in the same clock here, so we can know at what time the number has to be uh, regenerate. Okay, so the comparison of digital and analog system can be seen in this table. So digital communication is actually, the circuit is very cheap, okay? So it can have high security or privacy. And just now it says it can enhance capability where the data can be voice, video and data transmit over a common system, okay? And the corrections are easily reconstruct by a coding, okay? But it has also the disadvantage such as very large bandwidth, so it needs um, higher frequency to transmit, and the cable also very the one that can bring high bandwidth, and synchronization problem is also have to be considered, okay? And for analog, it's not it's also expensive, but it not as digital. It has no privacy, and if different sources, it cannot merge the data, and there is no error correction capability. But analog system is using smaller bandwidth, and the synchronization is easier. Alright, so this is the history of the communication when it start in the year 1820. Oersted create these magnetic fields, and then if we heard about Henry and Faraday's laws, they started that the magnetic fields could produce the electric fields and vice versa. And then Morse code, remember, they uh, create telegraph. So this telegraph can give you message by certain shapes of dots, okay? And then we also know James Maxwell. They predicts or introduce the electromagnetic Maxwell equations. And then Graham Bell first invent the telephone, and so on, so on. Right now we are in 2020. We are having more and more communication or electronics application. Okay. Okay, so for a conclusion, we have these two types of bounded and unbounded. And also we have two types of analog and digital communications. Okay. So I think that's all the important points in chapter 1 of these books. Inshallah, I will continue our lecture next one with chapter 2. Okay, so that's all for today. Thank you for listening, and if you have questions, you can always message PM me, right? Okay, Sadaqallahul Azim. Assalamualaikum warahmatullahi wabarakatuh.